fast on them at all. Like, I mean, I just feel like I can't get back.
I have to like,
I know that like your power
stop for a second before I go back.
I mean, I'm gonna argue at hold, but
I got it this time.
Nope, it's late.
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 Late. Coming on Friday.
Is that what you had to do?
This one we got like 65 on the test.
Come on, I didn't even have to come in. I'm in kids' None of my classes.
It was late for Mr. Olson's like, did you get it or do I have to bike to your house?
What was your
He set up Friday and I'm going to be with
Who's gonna play for your house?
Well, we live like down the road from each other. And I'm like, no, I got it.
So do you guys like put your own together?
No.
carpool.
Well, so my car is broken from driving
Maybe-
my parents' minivan.
I was gonna say, it'd be kind of funny if you guys, like, you drove some days and he drove the others. Like, Tuesdays I pick you up, Mr. Olson.
Well, then I have to take a girl that lives right by him to school. So I mean, Marty's driving fast as hell.
There's Mr. Wilson and Abby.
In Kansas.
And Kansas.
It's not
Nick, you're
awkward.
leaving
It'd be all
Mr.
He'd just be like, can you turn the radio down?
I'll give you Tyreek Hill.
Should I ask him if he wants to serve you?
He probably thinks it's
He's the one that told me when you leave, do you get it or do I have to bike to your house?
Okay, guys. So, in number 4, we have the square root. So that means there's a little 2 there. The square root of 5, though, can't be broken up at all. It's just 5 and 1. So the square root of 5 will stay in. However, r to the 5th, it's really r to the 5 over 2. So if you guys recall, it's been a few days. 2 goes into 5 how many times? Twice. So we have 2 out here. And then there's a remainder of 1 because it's like 2 times 2 is 4, and so we're 1 short. So it'll be like a r to the first inside. Same thing goes for number 5. Is I'm going to change these all to fractions.
Oh, yeah.
So we have the 4th root. Now 7 to the 8 over 4 is going to be 7 squared because 8 over 4 is just 2. So I can pull that out. There's no remainder, so there's nothing left inside. And I think I just changed that to 49. And then x to the 5/4, 4 goes into 5 once with a remainder of 1. And then 4 goes into 6. I wouldn't simplify that. 4 goes into 6 one time with a remainder of 2. So x, y, and then this will be the 4th root of x, y squared. Okay. So, we'll be continuing our notes from last time, so hopefully I still have those. So the 5-6 to 5-7 day 2 notes.
At home. So then, you know, I have to read my homework.
Make some voice.
We only did that a little bit. I cannot remember the order.
You guys make fun of me?
No, we didn't.
Yeah, keep blaming you have to.
Yeah, and then you were like, see, kids,
Okay, I did not say that.
no, Mrs. Donnie. And I was like, that's a nice thought.
Okay, if I wasn't making fun of Kinsey, then there would be no point.
And then you guys did
Yeah.
I actually was I saw it.
Oh, Laura, so I'm sorry I'm so bad at sports.
Abby, you're freaking terrible.
Nick, shut up.
Hey, the S word.
He started it. all of them over there just made fun of me.
So
this
next
whole
time-
And I'm sick of getting made fun of by them.
Kenzie's like, I love you.
Yeah, I'm real tired. Okay.
Oh boy, you guys.
Let's take this outside.
We're gonna have to go to therapy and like
Yeah.
everyone's gonna have to hold the teddy bears.
It'd be like couples counseling for algebra too. Couples.
Me and
Oh,
Kenzie
like,
were
you
just
know,
like,
like relationship counseling.
I hate you.
No, I always see the billboards on 23
Here's this way.
when I'm driving to Fond du Lac of marriage counseling.
And you think, oh,
There's also billboards for a lot of other things on the way.
Yeah, I think of Kinsey.
that's so nice.
Okay.
I didn't mean
Does
to.
anyone need a copy of these notes?
I didn't mean to.
You're gonna take his test, I don't think it's
Yeah.
You have these, right? Anyone need them? Okay. So, again, this is going to be a time that you guys are going to be really glad if you guys have the calculator that simplifies radicals for you for most of these problems. But then some of them, that one won't do as much for you. So, one of the things in terms of fractions, we can't have a radical in the denominator. So there can't be a square root in the denominator.
No square root.
There can't be a square root in the denominator. Now, I'm going to talk about this first because a lot of you guys, your calculators will simplify this for you. But once we get into like a cube root or a fourth root, it won't. So you want to make sure you know how to do this by hand as well. So in order to get that square root out of the denominator, I can't square the top and bottom. That doesn't really do what you think you want it to do. So what we can do is we can multiply the top and bottom by the same thing. What do you think we should multiply by? Any thoughts? So we get rid of that square root in the denominator. 4. So you multiply by 4, then it becomes 4 square roots of 2.
2.
Multiply by 2, then it becomes 2 square roots of 2.
1.
And then it doesn't
0.
change. Oh, then a 0 in the denominator, that's bad. All right, so we're kind of stuck. So what you want to do is you'd really like to multiply it by itself. So we're going to multiply the bottom by the square root of 2 and the top by the square root of 2. Now, square root of 2 over square root of 2 is just 1. So it's okay to multiply the top and bottom by the same thing. What is the new top of the fraction?
Square root 2.
Square root of 2. Square root of 2 in the numerator is just fine. Like, they don't care if there's a square root in the numerator.
Weird.
What does the bottom become?
1.
Not 1. What's it?
2.
2. It becomes 2. Because it's square root of 2 times the square root of 2, which will be square root of 4. And square root of 4 is just 2. So this is considered a better fraction than the first one. Now, I wasn't there when the math people voted about this, so you can't be mad at me over it.
Sure?
Yeah. I'm a few years younger than when they figured this out. But they decided that we can't have square roots in the denominator, so we have to get them out of the denominator. So, like in example 5 here, we have the square root of 5/4. Now, one of the things I want you guys to notice is the big square root can be separated as 2 separate square roots. So I can make this the square root of 5 over the square root of 4. Why is this good?
They're both square roots.
They're both square roots. There's something really good about this. Do you see it?
Square root of 4 is 2.
The square root of 4 is 2. There shouldn't be no radical in the denominator anymore because the square root of 4 is a nice number. This ends up being the square root of 5 over 2, which is fine with us. As long as it's simplified as much as possible and there's no square root in the denominator, we're good. So example 5. Any thoughts on what we could do? So I don't like that square root in the denominator. So what are we going to try to do? Or what are we going to do to get rid of that? Multiply it by itself. So we're going to multiply it by the square root of 3. Now, whatever I do to the bottom, I have to do that to the top as well. So to multiply the top by the square root of 3 as well. Whenever I do the bottom, do the top. The top, we really don't care how messy it is. As long as the bottom's a whole number, we're okay with that. So on the top, what does this become? Square root of 2, square root of 3 is really, yep.
4 square root of 6.
Yeah, you just write it as 4 square roots of 6. So the top, just I can multiply the 2 times 3 together. Those are like radical, or those are radicals we can put together. And then on the bottom,
3.
it's just going to be 3. It's going to be square root of 9, or just 3. Now, here's a question. The square root of 6 over 3, we don't want to, or I guess this is a comment, we don't want to simplify that because this has a square root and this doesn't. So we're just going to leave that the way it is. Now, if they're both square roots, we might be able to simplify. Or if they're both outside the root, we could simplify, but we can't do anything else with that. How about number 6? What do you guys want to multiply by?
Square root of 3.
I would multiply by the square root of 3. A lot of times students want to multiply by 2 square roots of 3, but you don't need the 2. The 2 is fine the way it is. We just want to get rid of that square root. So the top becomes 6 square roots of 3. The bottom becomes 2 times the square root of 9. So 2 times 3, so it becomes 6. So what's this going to end up being? Square root of 3. These are just going to cancel.
Oh, snap.
So square root of 3 over 1 or just square root of 3. So to be honest, every one of those, I think you guys can put into your calculator and simplify it for you if you have the calculator that does that. Sorry, kids, you do not.
Yeah. It's okay.
Sorry. So not everyone has that calculator. So I do want to talk about the why behind that because these next 3, if you don't know how to do this by hand, these are impossible in your calculator. So your calculator is helpful for the top 3, some of you, your calculator. The bottom 3, if you don't know what you're doing, you're going to be kind of in trouble. So that's why we want to know how to do this by hand. So we have 5x over the square root of x. I don't like that square root in the denominator. So if you try putting that into your calculator, I do not believe your calculator will be able to simplify it for you because of the variable. So what do you guys want to do to get rid of that? Multiply by the square root of x.
Wow. I could be here and I'm saying next to her.
Because I didn't want it to be that loud if I was wrong.
I have mom ears. I hear like the kid cough in the other room. Mr. Donnie who hears nothing.
If they say a bad word, you're like, what was that?
The kid, you know, dog's puking and Mr. Donnie who hears nothing, you know.
Or he says that so he doesn't.
Right, I know. Mom ears. It's okay. I can go back to sleep easier. Alright, so I multiply these together. So I have the square root of x times the square root of x is the square root of x squared. What does this become on the bottom?
X.
Just x, because square root and square cancel. So I have 5x square root of x all over x. So what can I simplify?
X.
X's.
What are you laughing at me for?
So that would be considered the simplified version there.
I wonder what people did in the olden days without calculators.
And a lot of long
like
math
They
problems.
just count rocks or
Yeah.
whatever and
And if they like miscounted, they get.
Oh. Let's go back. Alright, so this is where these get a little bit trickier, is when we have a cube root and we want to get rid of that cube root. Because if I do the cube root of 3, or so if I just multiply, you might say, well, why don't you just multiply by itself? So I'll show you what we get if we do that. If I just multiply it by itself, cube root of 2 times the cube root of 2 is going to be the cube root of 4. And if you check cube root of 4 in your calculator, that's not a very nice number. So when we have cube roots, what are we looking for? You guys remember when we're simplifying them? We're on groups of 3, right? So I would really like it if there was 3 of these. Ethan doesn't like that. So I'm really going to multiply it by the cube root of 3, or the cube root of 2.
I thought something completely different. That we were going to have to do the method where we like get 3 of them. And I was like, that's not possible.
Oh, I see what you're saying. So,
Kenzie, why are you laughing?
okay, so we can multiply by this. So I basically want to multiply by 2, 2, and 2, the cube root of 2, 2, and 2. Because what is that if I multiply that all together?
6.
Careful. 2 times 2 is 4, times 2 is 8. Cube root of 8
It's okay, I thought
is a nice number. She got a 16. Oh, good. We're all doing well here. So this is good when we get this. If I do this to the bottom, I'm going to have to do this to the top. But rather than doing this 2 times 2, what could I write that as? 4. Yep.
Jeez, what is this?
Some sort of hocus pocus. And then cube root of 8 on the bottom is just going to be 2.
3, okay.
Oh boy. Oh boy.
Does it get easier?
Yeah, it usually gets easier after we do it. No. Yeah.
I know, it makes my head want to explode.
And you guys were talking about how we just did a little bit last time, and then
Yeah. Thursday Abby didn't know Monday Abby would be like this.
Thursday. I think the stuff on the backside's better. I guess maybe it does get easier.
Well, she's lying. I'm gonna throw my pen.
I'm gonna throw out your pencil.
Pen.
Pen.
Who are you gonna throw it at?
You, Maddie?
Oh
Okay. So I have cube root of y on the bottom. So right now I have cube root of y to the first. How many cube root of y's do I want?
Oh, flipped on
To
that.
the third. I want this to be, so what I'm thinking of is I want it to be the cube root of y to the third, because then it'll just be y. So if I already have a y to the first, what do I have to multiply by?
3. 2.
What am I missing? If I have 1, how many more do I need?
2.
I need 2 more. So I'm going to multiply the top and bottom by the cube root of y squared. Now the bottom's going to be what I want it to be. It's going to be the cube root of y to the third. I'm running out of space there. I'll write it down here. And the top's going to be the cube root, and I can probably put those together because they're both cube roots, so 7y squared. So it's just going to end up being a y on the bottom, because the cube root of y to the third is just y. So the good news is the backside is, I think it's a little bit easier. But should we do some practice with whiteboards before we put the backside?
No.
Or would you rather you guys need a break?
Yes.
Yes. Just don't do it.
You know how much I've done on Monday? Not really that much compared to other days, but still, I just can't do more math. We play with soil in that.
I work once a week. I work Saturdays. My paychecks are $60. For working. And he was in there 2 days for 3 hours.
And we were like, we were like talking about like people.
So does Banter. He's very, he gives away his money to charity.
I literally make like
For chores.
$8.25 an hour.
There's a 17-year-old.
I know, that's what we were saying, as we're supposed to be here, we're gonna start this room.
Becoming stocks.
All right. Would you rather give up your favorite food for a year or give up candy forever? Get up and move. Give up your favorite food for a year or give up candy forever? I can live without candy. We're living out candy. We're living without candy. What? All right. Would you rather have to eat ice cream every day for a year, so they're force feeding you ice cream every day for a year, or go without ice cream for 2 years? Doesn't like ice cream over there.
Kinsey, shut up. I've seen you eat ice cream. Get your butt over here.
Just because I've had ice cream doesn't mean I give up. He's lying.
All right, would you rather ride the scariest roller coaster in the world or bungee jump off the tallest building in the world? So roller coaster or bungee jump?
Ed, get off your phone. This is a fun school activity.
And you haven't moved. Yeah, right.
I'm waiting for a good option to be over there.
All the good options over here.
Yeah.
All right, let's see how nice of a human you are. All right, would you rather donate an organ to a friend in need? So one of your friends needs an organ, or you would sell one to a stranger for lots of money. So you give it to a friend as a gift, or you get lots of money for your
What type of friend you are? Money is money.
Abby, get off your phone. Dude, this is really unacceptable.
Stop it. Honestly, right now, this is supposed to be an activity to get you guys moving. So you're reincarnated as, would you rather be reincarnated as a lion or as an eagle? Because you're going to be a new animal when you, either a lion or an eagle. Lions sleep like 22 hours a day.
But the males do.
The males, yeah, I suppose.
The males don't do it. Yeah, but lions can't fly.
Wake up as a male lion. Yeah. Here, right.
Oh yeah. One of the eagles around my house ate one of my chickens. He's a devil chicken. He came down. Yeah,
The devil chicken.
that was the one he ate. He like took its chicken.
All right.
People still
Big,
alive?
this is a deep question. Would you rather have pizza rolls or bagel bites? Pizza rolls or bagel
I
bites?
dip my pizza rolls in sour cream.
Ooh, that sounds good. I used to dip my pizza rolls in like French onion dip.
What are bagel buns?
Bagel bites or bagel bites?
I've never had either of these options.
No, they're like totally processed food. It's fine. You're probably better than. All right, guys. Big argument. Burger King or McDonald's?
Gotta respect it.
I wish they were.
Nick, get over here and respect my McDonald's. Nick.
Why did you have that again? That sounds
I
really
refuse to take something new.
I'll make sure.
the creamier. Okay, which kind of peanut butter? Creamy peanut butter or chunky peanut butter?
No, kind of nasty. That is nice.
I feel like that's one of those things you should ask on like a first date.
What if not?
Yeah. And then you don't just buy 2 jars of peanut butter.
Want to die on this crunch in the world? We're rich over here.
That's like the type of milk too, like 1 or 2% skimmed. Like,
When you get so you go back, it's like if you have something, you can always hold on to it. Really?
Yes.
So it's like chocolate.
True honey.
Okay, you can do that. Chocolate over there, vanilla over here. Chocolate or vanilla? For anything.
I'm sorry, what'd you say?
Chocolate or vanilla?
Which one's chocolate?
Chocolate's here.
Now you're lying again. I told you, see this girl? She's lying.
Okay.
Play if you're gonna lie.
So no, no pressure, but you can get rid of one of these two classes. You guys can either get rid of history class or math class. You get rid of history or get rid of math.
I mean, World War II.
That's all we ever
My favorites are over here.
Maddie, be quiet. You're
Okay.
lying now.
Would you rather drive a creepy ice cream truck?
Yes.
That's your car. Or the Oscar Mayer Wienermobile?
No. Oh yeah. Oh
Maybe
yeah.
as in it looks like it's haunted or something.
Or that looks like it's gonna steal a child, like something like that. Yeah.
My dream was to ride
I'm driving my parents' minivan right now.
Is this still recording?
All right.
Yes.
Would you rather hang out with Curious George or Winnie the Pooh?
Definitely you guys.
So I said that.
Oh.
Curious George had the
Use the front of the guy.
Serious George being best friends with I don't think Curious George can even Winnie the Pooh on the other hand.
Alright. Last one. Would you rather marry for money or for love? What did you say? Marry for money or for love? What if he's really ugly and rich, but then
Who did that?
Alright. Okay guys, head back to your seats.
If you just get married, that's gonna be love. That's so sad. I mean, for money. For money. For money, that's sad. Sorry, my mind's still on the yellow. If you marry a monkey for his love, the money goes, but the monkey remains as is.
Egyptian black and white.
That doesn't make any sense.
Okay.
Hey, then I would show up to like the next house to like, oh, murdered your husband. I'd be like, I don't know what I did.
Kinsey.
Well, I'm not visiting you in jail. Or sleeping over at your house any.
That's fine. That's him even there with me.
That was not my fault.
Yeah, that was sorry.
You would marry me for money? This is all I got on me.
I made a lot of money. Jax, were you on that side with the gold diggers? That same.
Yeah, I can see Jack sitting there.
And you were literally over there.
No, I was
No,
not.
she said it'd be sad to do that.
Yeah, but is it, she might be sad, but it's worth it. I mean, you can't put it in one.
Why would I be sad? Until your mother's unhappy.
That's the guy I broke up with. You're gonna hear this. The guy I broke up with for Mr. Donahue is a lawyer now. So I
Yeah, I thought you were going to say.
Wasn't he the
No.
one that was really mean to you?
Yeah, he used to call me Fatty. That was that one.
Wait.
That was his nickname for me.
You dated him and then you saw Mr. Donahue and then you broke up with him?
Kind of. Sort of. I mean,
Whoa. But it's
I
okay.
mean things happen. So
He didn't sound like he was worth it anyway.
no. So like radicals have to be the exact same radical. So the exact same number underneath the radical.
Does he do it with Gruber's law offices?
No.
That's all.
He's David Gruber.
Yeah.
You really didn't
So,
so.
is he always married David Burr? No. No, he lives in like Washington, D.C. now. He doesn't live here.
Oh, he's a fancy lawyer
Yeah.
now. This is
Stop. You'd be a billionaire beside you married someone.
Okay. So, the same number underneath a radical, like radicals have to be like square root of 3 and square root of 3. So that it has to be exactly the same like that. And what we do is we're going to add or subtract the numbers in the front, kind of like with variables. So we're going to add or subtract the coefficients.
Tell that to Mr. Donahue. I almost married David Groove.
Yeah, that's what the kid, yeah. I'll tell him that since you guys said it. So, square root of 3 and square root of 3 are like radicals. What I'm going to do is take the numbers in the front and add and subtract them, or add or subtract depending on what I need to do. So 2 plus 7 would be 9. And then we just leave the radical the way it is. So 9 square root of 3, because we're adding these. Now I can't simplify this because the 9 is not part of the root at all. And then these two are not radicals, but they're like terms, just like normal like terms. So 5 minus 2 would be, you say 4, 3.
Lindsay, you gotta say it louder.
But I don't.
She's not
5
confident.
minus 2?
Here's the thing, Abby. If I get it wrong, then you'll be like, Richard, you're such an idiot. I can't believe you get it wrong.
I didn't. I would never call you an idiot. I would never call you an idiot to your face.
Yeah, thanks.
That's exactly what Abby said. Every single spot.
Okay.
The tables have turned.
All right, guys. So now this next one, that seems all well and good here, except if you look at this next one, none of these radicals are alike. So you would think that you could just stop, right?
They're all divisible
Okay,
of
come on.
3.
There's more we can do.
They're
What's
all
that?
divisible of 3.
They're all divisible by 3. And now that's kind of... Huh?
Ow.
Oh, that's your sheet from the other day. Okay. I was like, why are you taking 2 steps and up? So they are all divisible by 3, and that's kind of a great way to realize that we can actually simplify these. So we're going to break this up, but I'm going to suggest you use the fact that you know that 3 goes into all of them to kind of help you. What times 3 gives you 27?
9.
9. So this one's easy to simplify because I know it has a 3 that goes into it. And we'll simplify that in a second. And then the 12, we know 3 goes into that, so I'm going to break that up as
4. 3.
4 times 3.
Yeah, I got it.
Now why this is good is because square root of 9, I can do that. Square root of 9 is just 3. Lots of 3's here. So I end up with 9 square roots of 3. This is minus 7 square roots of 3. That minus sign kind of changed into a weird thing there. Minus the 4, square root of 4 becomes 2.
-2.
Okay. Now I'm going to add or subtract their coefficients. So 9 plus 7 minus 2.
What? I think it's -7.
9 minus 7 minus 2 is I say something different, sorry.
Yeah, it's 0.
It's 0, yep. There is no, it's like 0 root 3, which is just
Root 3.
0. Oh. 0 times anything is just 0.
Wait, oh yeah.
Now, I just realized all the simplifying radicals we did were with square root of 3. It's not always going to be the square root of 3, it just happen to be the ones that showed up here. So,
She has favorites.
yeah, square root of 3 is currently my favorite radical. Okay.
Just like I'm her favorite too.
So, we're going to simplify with our radicals here. Now, hopefully you guys noticed this is, rather than adding and subtracting, these are FOIL.
And David Gruber's her favorite lawyer.
He's at like every Milwaukee sporting event.
And
I'm
that's
wondering
how
what
you
he,
go.
I'm wondering why he, like what he does now that there's no.
What if he changes his name?
What do you mean?
David Gruber.
How would changing his name help him to get to the sporting events?
He's actually your high school boyfriend.
Oh, no.
His commercials,
Hey,
he's in his house.
That could be connection.
You can marry his daughter.
It's not like people change the way they look that much. I
Oh,
mean,
he's-
I recognize it.
That's why.
Yeah, that's why I told you that.
Right. And now he's, yeah.
Actually, I think his daughter's kind of older than Garrett.
I'm looking this up right now.
I don't care.
Daughter of David Gruber.
I have looked up if he has any 17-year-old grandsons or something.
Because I think the grandkids are on one of the commercials.
Oh, here. He also has little kids in there. It's kind of scary.
How old's his daughter?
I don't know. I'm on this photo.
Yeah, she definitely doesn't look like she's in high school.
She'd be a
Okay.
cougar.
So we're multiplying, you guys. 2 square roots of 3 times the square root of 3. What do we get?
2 square root of 3.
Which is,
No, wait. You get 6.
Yeah, because you get 2 square roots of 9, which is 2 times 3, which is 6. So just go ahead and. Then I have to multiply 2 square roots of 3 times 6 square roots of 5. So plus, you're multiplying the numbers in the front. So 2 times 3, or 2 times 6, 12. Square root of 3, square root of 5 is going to be square root of 15. You multiply.
Put 8.
Oh, I put 18. Good.
Yeah, that's why I was like,
Someone said 8, so I was confused.
there's genius over here.
David and Nancy have been married for 36 years.
Oh, that's nice.
what are you talking
See, that's longer than I've been. I mean, I would have been like 6 years old. So he couldn't be my boyfriend. Or he was a married man, and that's why I left him. The plot thickens. Yeah, totally. All right. Now I have 4 square roots of 5 times the square root of 3. So 4 square roots of 15. So that is that inner term. And then last, 4 square roots of 5 times 6 square roots of 5. 24 square roots of 25. 24 times 5
Thanks, Kizzy.
at 120. Okay.
Wait. I thought you did the same.
Oh,
So
his
we can
daughter's
multiply
married.
if they're different radicals. You can
Oh.
only add or subtract from the same. So good question, you guys. Real quick, Jordan was just clarifying. We can multiply square root of 3 times square root of 5 because they're multiplying. The adding and subtracting, they have to be the same. So now we can put these two together because they're the same radical. And then we can put the ones together that aren't radicals at all. So like 6 and 120 go together, so 126. And 12 square roots of 15 and 4 square roots of 15. So it'll be 16,
Square root of
15. You leave the radical the way it is when you add. So it kind of incorporates both. Why don't you guys try example 11? I'll give you guys a minute here to do that.
Garrett, his daughter's married.
And she's a doctor.
She's gonna leave him for you.
I'll be right back. I just realized that.
David and Nancy. 6 years.
Mr. John, he always tells me if I die, he'll remarry, but not for love. I'm like, great, thanks.
Oh, so he wants to marry David Gruber's daughter.
Right.
Garrett's gonna have some conversations.
Garrett, Mr. Donahue.
I'll go to the fun box.
Sit your finger
watches the YouTube video.
Yeah, he's like, for some reason, he's like, what's this channel, Nicole Dunn? Let me watch algebra.
I think it's the girl I dated back in the day.
But that was when my name
I
was
feel like
not
if Tom got me, he'd be like, there's some scrub in the streets.
Okay. How's this going, you guys?
Oh,
Do you guys notice something unique about this one?
Yes.
Yeah, the middle two terms on this one are going to cancel out. These are called conjugates of one another. Sounds like a disease, but it's not. It's actually kind of a good thing. So 12 times 12 is 144. 12 times the negative square root of 3 is going to be a negative 12 square root of 3. Then I do the inner, so that's going to be positive 12 square root of 3. And then last, I get a negative square root of 3, square root of 3, so square root of 9. And we'll be able to simplify that. So these middle two terms cancel out. We like when that happens. We'll use that in a second in our next type of problem. So I'm left with 144 minus the square root of 9, which is just 3. So we're able to get rid of the radical altogether in this problem if we use this conjugate.
I like those.
Yeah.
Hey.
What? David Gruber's son?
I don't know. I think Mr. Dad, he might win in a fight against.
Between with Gruber or with Garrett?
The other fighting for Mrs. Donahue.
Mr. Donahue has a crazy streak, I'm going to tell you. Like, if he's actually angry, I don't know.
Does he get I don't know, like a guy.
Yeah, did the guy flirt with you in public
Dude, I'm
and
learning
punched
how to
you?
lead.
Yeah, you would slap his soul out of your body.
Put you into a ball and shoot you in the best.
Okay.
I'm like Rocky Balboa and Muhammad Ali put together with a little bit of Mike Tyson sprinkled in.
Garrett would be a fighter in a fight.
He'd bite Mrs.
He was late for our last running class.
Really?
Instead of having like 2 ran.
Why? Oh, Garrett?
Yeah. That's why he was late to our last class.
Because you're running laps.
I was running on a treadmill.
Okay. So, reminder that we can't have radicals in the denominator. So, since we can't have radicals in the denominator, we have to get them out like we did in that problem a while ago with the square root of 2 in the denominator.
Already forgot.
However,
They cancel out.
well, this one doesn't because there's a 2 and a 5.
No, positive and negative square roots.
Oh, so good point. So I see what you, okay, so let me talk about that for a second. So you see those two and you might be like, I can cancel those. Let me show you an example where that doesn't quite work. So if I have 4 minus 5 over, well, let's do plus 5, and then 4, let's change that number, sorry. 4 plus 5 over 3 minus 5. So this is really 9 over negative 2, right? If we simplify that, or if we combine things, right? I'm trying to show you why we can't just cancel these two. So Garrett's suggesting that we can just cancel it, and I'm sure some of the rest of you guys are thinking that as well. You can't just cancel those 5s because of the fact that there's addition and subtraction between them. So this would be 4 over 3, which is not the same as this. So you're not able to cancel with addition and subtraction like that. You can only cancel like that with multiplication. So let me show you what I mean. So if I have 2 times 3 over 5 times 3, I can now cancel the 3. So that's going to be 2 over 5, which is the same thing as 6 over 15. It's okay to do that. But since the addition and subtraction show up, we can't do the canceling. So what we're going to do is actually use that conjugate from that last problem. So what we would like to do is get rid of the radicals on the denominator. So I want to use the conjugate. What's the conjugate of 5 minus the square root of 3? Yeah, so look at those parentheses from before. It's just the exact same values, just the opposite side. But if I do that to the bottom of the fraction, I have to do it to the top as well. So we have a couple of things of FOIL to do here. And I don't know if you guys want to do you want to completely simplify the top before we work on the bottom? Just work on the bottom. It's okay. 25.
That's what Garrett said, so you gotta do it.
It's just one thing.
So I foiled on the top and the bottom. Now I'm going to try and simplify on the top and the bottom. But again, I can't just simplify. I can't cross things off on the top and the bottom of the fraction. I have to combine like terms. So this is 7 root 3. And this is 3. This is 2 plus 5, right? You can't just cancel the 9. Same reason you couldn't just cancel the 3. I know, it's hard to remember all that. Now on the bottom down here, these guys cancel. So 25 minus 3. The square root of 9 is 3. I think that might be it. So there's, even though that number still looks kind of crazy and awful, it's considered simplified because there's no radical in the denominator. So example 15, why don't you guys take a minute to decide what you would multiply by, and I'll start working through it. Again, we don't want a radical in the denominator.
See, she used it.
What?
You wouldn't use the hand sanitizer, and you said no one uses it except you. Mrs. Donovan just used it.
So I'm going to multiply 6 plus the square root of 5. Is that what you guys used?
Yes.
Okay, good. Because if you didn't, there's probably a bunch of a mess of a problem there. So I'm going to multiply the top and bottom by that, because that's considered that conjugate. And again, I probably write out more steps than maybe you want to all the time. And if you skip a few, that's fine as long as you get the right work. I want to write out square root of 25 so you're not unsure of what I was talking about there. So I'm going to combine some like terms here. These guys will cancel. This is like a 1 square root of 5 and then a 12 square root of 5, so 13 square root of 5. And this will be 5 here. And so then I'm going to combine the 6 and 10 to be 16. And that's as simple as it can get. Oh boy. Oh boy.
for the next lesson.
Okay.
My mind is like,
All right. Last example here, and then I'll give you guys the rest of the time to work, just because I know these are tough.
Sweet baby rays, is that what that part is called?
yep.
I'm gonna use it anymore.
Okay, so this one's just a distributive property problem here. I'm going to distribute this in. And we're multiplying the square root of 3, or the cube root of 3, cube root of 2 times the cube root of 4. I was saying that weird. So the cube root of 3 times the cube root of 4 is going to be the cube root of 8, because 2 times 3 is 8, or 2 times 4 is 8. Sorry. And then the cube root of 2 times the cube root of 12, 24. But I do want you guys to check and see, can you simplify that? Cube root of 8 is 2.
2. Plus 8.
Careful, no. Cube root of 24 is not 8.
Oh, yeah. Because you have to do
Remember, we need groups of 3.
Yeah.
So I break it up as 8 times 3. 2 times 4, 2 times 2. There's my group of 2s. So 2 plus, so this 2 will pop out, and there's just going to be a 3 left inside.
3?
Now this is where we're going to stop. You can't put the 2 and 2 together because they're not like terms. So this is where you leave it. Okay? So homework is on 2 separate pages because of the fact that this has been 2 separate sections. But if you notice, like when you actually count it, I don't think it's really that awful in terms of questions, the number of questions. All right, questions there all? Yes. Yeah, the rest of the time though.